Welcome to long-form content of Tech Bytes and News. This is a compilation on latest news and articles featured on Hacker News. You can find the original links of articles in the description. Please like and subscribe to support future content. Hope you enjoy.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a significant development: the FTC's action against GoDaddy for allegedly lax data security. It's a big deal, folks.
Absolutely. GoDaddy, a massive player in web hosting, facing the FTC. This is juicy stuff. What exactly are the accusations?
The FTC alleges GoDaddy failed to implement reasonable security measures since 2018. They're accused of not properly managing assets, software updates, risk assessments, and logging security events. Essentially, a pretty significant lack of due diligence.
Wow, that's a long time to be allegedly operating with such vulnerabilities. What were the consequences of this alleged negligence?
Several major security breaches between 2019 and 2022, resulting in unauthorized access to customer websites and data. Consumers visiting those sites were exposed to risks, including redirection to malicious sites. It's a serious breach of trust.
So not only did they allegedly fail to protect their customers, but they also allegedly misled them about their security practices?
Precisely. The FTC claims GoDaddy made misleading statements on their website, in emails, and social media ads, implying stronger security than actually existed. They even allegedly claimed compliance with the EU-US and Swiss-US Privacy Shield frameworks, which clearly wasn't the case.
That's a serious accusation. Misrepresenting security is a huge problem, especially for a company like GoDaddy that handles so much sensitive data. What's the FTC's proposed solution?
The FTC's proposed order is pretty comprehensive. It prohibits GoDaddy from making further misrepresentations about their security and mandates the implementation of a robust information security program. Think along the lines of what we've seen in other FTC cases, like the Marriott settlement. They'll also need an independent third-party assessment of their security program, initially, and then every 2 years.
An independent assessment. That's a strong move to ensure accountability. It seems like the FTC is sending a clear message to other web hosting companies.
Absolutely. This isn't just about GoDaddy. It's a warning to the entire industry. The FTC's Director of the Bureau of Consumer Protection, Samuel Levine, emphasized the importance of bolstering security systems to protect consumers globally. This case highlights the critical need for robust security practices and transparency in the web hosting sector.
I agree. This case underscores the significant responsibility web hosting providers have in protecting their customers' data. The potential penalties are substantial too, aren't they?
Yes. Each violation of the final consent order could result in a hefty civil penalty, up to $51,744. That's a strong incentive to comply. The FTC is clearly serious about enforcing data security regulations.
This whole situation is a stark reminder of the importance of choosing a reputable web hosting provider with a proven track record of strong security measures. It's not just about price, it's about protecting your data and your reputation.
Exactly. And remember, folks, the FTC will never demand money or threaten you. If you suspect a scam, report it immediately. That's all the time we have for today's Tech Bytes and News. Thanks for listening, and have a great day.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving into a fascinating post by Alexander Mikhailian about what he calls forgotten software engineering principles. It's a cautionary tale, really, about an organization's migration from WebLogic to Kubernetes and the resulting challenges.
Yeah, I saw that post. It's a compelling read. The core issue seems to be a loss of understanding of fundamental distributed systems concepts during their migration, right, Thoristed? They moved to a new architecture without fully grasping the implications.
Exactly. They went from a WebLogic setup with built-in distributed transaction support, 2 servers, ensuring data consistency, to Kubernetes, keeping the 2-instance model but losing the crucial transactional guarantees. They essentially forgot why the old system worked so well. The resulting race conditions are being manually patched with reboots.
That's insane. So they replaced EJB with Spring Boot. introducing more application-level state without a mechanism to synchronize it across instances. A classic case of moving fast and breaking things, but without the fixing things part, it seems.
Precisely. And it gets worse. Their decision to ditch session cookies in favor of JWTs, ostensibly for GDPR compliance or API gateway integration, created a whole new set of problems. They now have CRS issues, difficulties downloading files, and a completely broken single sign-on experience.
The JWT approach, while generally secure, seems poorly implemented here. Passing JWTs in the authorization header instead of a session cookie is a major oversight. It forces reauthentication for every single page application transition, defeating the purpose of SSO. This is a textbook example of how a seemingly simple architectural choice can have far-reaching negative consequences.
Absolutely. The author highlights the complexities of downloading files. A simple GET request becomes a convoluted multi-part /form-data response because they forgot about content disposition headers. And the user experience? Awful. Screen readers are barely usable. It's a complete mess.
Nekti, it's a really striking example of how neglecting fundamental principles can lead to such a cascade of problems. It makes you wonder about the engineering leadership, as the author points out. Was it a lack of competition? Complacency? Or something more systemic?
That's the million-dollar question, isn't it? The author suggests a failure of engineering leadership. Perhaps a lack of a strong deontological code of conduct within the organization. It's a sobering thought. The HN comments suggest a simple fix for the cookie problem, using JWT's in-session cookies. But that's just a band-aid on a much deeper wound.
I see. It's not just about technical skills, it's about understanding the why behind established best practices. This case study is a powerful reminder of the importance of solid engineering principles and thoughtful architectural decisions. It's a cautionary tale for us all.
Indeed. A great reminder to always consider the broader implications of architectural choices and to never forget the fundamentals. Thanks for joining us on Tech Bytes and News. We hope you found this discussion insightful. Have a great day.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into the fascinating DeepSeek R1, a new large language model that's making waves in the ML community. It's a big deal, folks.
Absolutely. I've been following this closely. What makes DeepSeek R1 so special? Is it just another LLM, or is there something truly groundbreaking here?
Oh, there's a lot more to it than just another LLM. It's open source, for starters, which is huge for reproducibility and community involvement. But more importantly, it's designed to excel at reasoning, particularly mathematical reasoning. Think OpenAI's O1, but with a publicly available training methodology.
That's impressive. So how did they achieve this remarkable reasoning ability? Was it just a matter of throwing more data at the problem?
Not quite. While the base model was trained on a massive 14.8 trillion tokens, the real magic lies in their training process. They used a three-step approach: language modeling, supervised fine-tuning, SFT, and preference tuning. But the SFT phase is where things get interesting.
Interesting. So what's unique about their SFT approach?
They didn't just use any old SFT data. They created a massive data set, 600,000 examples of long chain-of-thought reasoning problems. That's a huge undertaking, and getting that data was a multi-step process itself.
Wow, 600,000 examples. That's a significant investment. How did they even manage to create that much data?
That's the clever part. They used an intermediary model, a sort of reasoning specialist, to generate much of that data. This model, inspired by R10, was trained using reinforcement learning, RL, with automatic verification. This is key. They didn't need human labeling for every single example.
Automatic verification? That's a game changer. Can you elaborate on that?
Sure. For reasoning problems, especially coding tasks, you can automatically check the correctness of the generated solution. Linters, code execution, unit tests, all these tools can be used to verify the answer without human intervention. This dramatically reduces the cost and time of data creation.
I see. So this intermediary model generated the bulk of the SFT data, which was then used to train the final DeepSeek's R1 model. But why not just rely solely on the RL approach like R10?
That's a great question. While R10 showed impressive reasoning capabilities, it had some usability issues. Poor readability and language mixing, for example. The SFT step, even with the synthetic data, helps to improve the overall quality and usability of the final model. It's a hybrid approach, combining the strengths of both R, L, and SFT.
That makes perfect sense. A balanced approach. So, what about the architecture of DeepSeek R1 itself? Is it anything revolutionary?
Architecturally, it's a fairly standard transformer decoder stack, 61 layers to be precise. However, it uses mixture of experts, MoE, layers, after the initial dense layers, which allows for greater efficiency and scalability. It's a well-established architecture, but the training process is what truly sets it apart.
So, in essence, DeepSeek-R1 represents a significant advancement in training methodologies rather than a revolutionary architecture. The focus on automatic verification and the clever use of an intermediary model are the key innovations here.
Precisely. It's a testament to the power of clever engineering and a deep understanding of the training process. The open-source nature of the model and its training methodology will undoubtedly accelerate further research in this area. And that, my friends, is why DeepSeek R1 is such a big deal.
I completely agree. This is a fantastic example of how innovative training techniques can push the boundaries of what's possible with LLMs. Thanks for breaking it down for us.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll catch you next time. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into the fascinating world of parametric speaker cabinet design. This blog post details a multi-year project culminating in some truly elegant 3D printed speakers. It's a wild ride.
Wow, sounds intense. So what's the core innovation here? Is it just the shape? Or is there more to it?
It's the complete package. The author, Cal Bryant, designed these speakers to be fully parametric, meaning you can adjust almost every dimension, driver size, enclosure volume, even the overall shape, all within the same design framework. He used OpenSCAD, a code-based CAD system, which is pretty hardcore.
Code-based CAD? That's unusual. What are the advantages of that approach? I'm intrigued.
Exactly. The big advantage is the complete control and repeatability. Once the code is written, you can generate different speaker designs with just a few parameter changes. It's incredibly efficient for experimentation. But it also presents some unique challenges, as Cal found out.
Oh yeah? What kind of challenges?
OpenSCAD, being CSG-based and not BREP, made some aspects, like precisely placing screw holes, a real headache. He had to resort to some clever trigonometry to get it right. It's a testament to his dedication.
So he basically programmed the speaker's geometry? That's amazing! But how did he actually build them? Did he use a CNC router, as one might expect?
Initially, yes, that was the plan. But, after a year of wrestling with a temperamental Mach 3 controller, he switched gears. He realized he could 3D print the entire thing. Can you believe it?
No way! 3D printing speaker cabinets? That's a bold move. What material did he use?
PLA filament. He even calculated the infill to match the density of MDF, which is pretty clever. But the printing process wasn't without its own set of hurdles here. He had some serious bed adhesion issues initially. It was a real roller coaster.
I see. So after all that, he had a bunch of 3D- printed speaker parts. What was the assembly process like?
He used epoxy glue and cleverly designed screw holes to align and clamp the panels during assembly. This is where the parametric design really shines. The screw holes are precisely calculated, ensuring a perfect fit every time. Ingenious!
That's brilliant! But, 3D printed speakers. Wouldn't they look, 3D printed? Did he do any finishing?
Oh, absolutely. He sanded them extensively, used filler to smooth out the surface, and then sprayed them with a textured bed liner paint. The final result is surprisingly sleek and doesn't look DIY at all. It's truly remarkable.
So the final product. Elegant, fully parametric, 3D printed speakers. But how do they actually sound?
Great. Absolutely great. He initially used an older amplifier that struggled with the third-order crossover, but after upgrading to a FOSI V3, The sound quality was phenomenal. He even measured the frequency response to ensure proper driver phasing. A true audiophile.
This is incredible. A truly impressive project. It showcases the power of parametric design and the versatility of 3D printing. Thanks for sharing this fascinating story.
You're welcome. And that's all the time we have for today's Tech Bites and News. Join us tomorrow for another exciting deep dive into the world of technology. Goodbye.
Bye-bye.
Welcome to Tech Bites and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into a fascinating monitor repair saga. It all started with a seemingly simple problem, a malfunctioning power button. But the solution? Oh boy, it was anything but simple.
I'm already hooked. What kind of monitor are we talking about here?
An LG 27UL500W, a multi-function control stick, not just a simple on/off button. The author, let's call him the repairman, noticed the button was getting progressively stiffer, eventually failing completely. He initially tried software workarounds, but those proved fruitless. The LG on-screen control software was particularly unhelpful, even comically so.
So, hardware intervention was the only option? Sounds like a fun weekend project.
Fun is a relative term, my friend. The repairman first had to carefully disassemble the monitor. It involved removing the rear housing, unsnapping the bezel, and then getting to the power button module itself. He emphasizes the importance of safety, as even unplugged, capacitors can still hold a charge. Always be careful.
Good point. Safety first. So, he got to the power button. Was it a simple solder job?
Not quite. He discovered the button was a complex assembly of thin, delicate button sheets. Think of it like a really tiny, multi-layered button sandwich. His old soldering iron, a 2016 model, wasn't up to the task. The tip was worn out, and even at max temperature it couldn't melt the lead-free solder.
Oh no! A soldering iron malfunction during a monitor repair? That's a meta-level problem.
Exactly. He ordered a new Pine-Sil V2 soldering iron, which he raves about, along with new tips for the old one. The new iron made quick work of the desoldering, but the button sheets themselves were incredibly fiddly. Tiny, magnetized tweezers, a real challenge.
I can imagine. So what was the root cause of the failure?
The culprit? Factory defect? He found a discolored, corroded button sheet and a detached component. It seems the button was faulty from the start, and the vertical monitor orientation may have just exacerbated the pre-existing problem.
Wow, that's a surprising twist. So, a simple cleaning and reassembly fixed it?
Not quite simple, but yes. He used deoxit to clean the contacts, carefully reassembled the button sheets, leaving out the detached piece, and resoldered everything. Success! The monitor's OSD now works perfectly.
That's a fantastic repair story. A testament to perseverance and a good soldering iron. I bet he learned a lot.
Absolutely. And a reminder that sometimes the simplest looking problems can hide the most complex solutions. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the world of monitor repair. Have a great day, and we'll see you next time.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving deep into CMU's Spring 2025 offering of Machine Learning in Production, a course designed to bridge the gap between theoretical ML and real-world application. It's not just about building models, it's about building products.
Right. I saw the course description. It sounds incredibly comprehensive. They cover the entire ML lifecycle, from prototype to production deployment, right? And it emphasizes responsible AI, which is crucial.
Exactly. They're tackling the hard stuff: safety, security, fairness, explainability, all within the context of MLOps. They even have a whole section on how to design systems that are robust to the inevitable wrong predictions a model might make.
That's a huge challenge. How do they approach that? I mean, you can't just hope for the best, can you?
No way. They delve into techniques for reliable deployment and updates, testing the entire pipeline, not just the model itself. They discuss MLOps tools for automation and scaling, A/B testing, canary releases, the works. They even cover detecting data quality issues and concept drift in production.
Wow, that's a lot to cover. What about scaling? Building a system to handle massive amounts of data is a beast in itself.
Totally. They address that head-on, exploring different architectural approaches like stream processing, batch processing, Lambda architecture, and data lakes. It's all about choosing the right tool for the job, depending on the scale and nature of the data.
And testing and debugging. That's always a nightmare with complex systems. How do they suggest tackling that?
They emphasize evaluating model predictions in production, testing the entire system, and leveraging lessons from software testing, automated test case generation, simulation, and continuous integration. It's a holistic approach. They really stress the importance of testing the whole system, not just the model itself.
I see. Interesting. So beyond accuracy, what other qualities do they highlight? Because accuracy alone isn't enough for a real-world product, right?
Absolutely. They discuss latency, operating cost, scalability, explainability, fairness, privacy, robustness, and safety. They even talk about offline operation and model update frequency. It's a really nuanced perspective.
And the teamwork aspect? Building these systems requires collaboration between data scientists and software engineers, right?
Yes. The course explicitly aims to foster that collaboration, emphasizing the need for a shared understanding and team culture. They even use a movie recommendation service as a major project, simulating real-world production conditions with 1 million users.
1 million users? That's ambitious. But it sounds like a great way to learn. So, what are the learning outcomes? What should students be able to do after completing this course?
They should be able to analyze trade-offs in system design, plan for model mistakes, design scalable data infrastructure, ensure pipeline quality, build testable and monitorable systems, consider system-level requirements like safety and fairness, and communicate effectively in interdisciplinary teams. It's a pretty comprehensive skill set.
It sounds like a fantastic course. I'm a little jealous I'm not enrolled. But seriously, the emphasis on responsible AI and the practical, hands-on approach is really impressive.
Totally. And the fact that they share all the course materials under a Creative Commons license is amazing. It makes this knowledge accessible to a much wider audience.
It's a great example of how academia can contribute to the real world. Thanks for breaking it down for us.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll catch you next time.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into a fascinating project, a dynamic 1.58-bit quantization of the DeepSeek R1 large language model. It's a game changer, folks. Seriously.
Wow, 1.58-bit quantization? That sounds incredibly aggressive. How did they even manage that without completely destroying the model's performance?
That's the million-dollar question, isn't it? They achieved an 80% reduction in model size, going from 720 gigabytes down to a surprisingly manageable 131 gigabytes. The key is their dynamic quantization technique. They didn't just uniformly quantize everything to 1.58 bits. No.
So it's not a uniform quantization? What's the secret sauce then?
Precisely. They cleverly leveraged DeepSeek R1's architecture. They identified specific layers, primarily the mixture of experts, MO, layers, that could tolerate lower bit precision, while leaving other crucial parts, like the down projection matrices, at higher bit depths. It's a nuanced approach. Brilliant, really.
I see. So they essentially tailored the quantization to the model's structure. That makes sense. But how did they determine which layers could handle lower precision?
They combined several techniques. Their own 4-bit dynamic quantization method, insights from the 1.58-bit LLM's paper, Llama.cpp's 1.5-bit quantization, and the Superweights paper. They even used an importance matrix to calibrate the quantization process for even finer control. It's a beautiful symphony of techniques.
Impressive. And what about the performance? Did this aggressive quantization significantly impact the model's capabilities?
Surprisingly, no. They tested it using a rather unusual benchmark, generating a Flappy Bird game. Their 1.58-bit version scored remarkably well, achieving 69.2% accuracy on their custom criteria, compared to 91.7% for the 2-bit version. Not bad at all.
A Flappy Bird benchmark? That's unique. But the results are impressive, especially considering the massive size reduction. What about inference speed?
On a 2xh 180 gigabyte setup, They achieved around 140 tokens per second for throughput and 14 tokens/s for single-user inference. Even on a CPU with just 20 gigabytes of RAM, it works, though slower. Amazing! They've made this powerful model accessible to a much wider audience.
This is truly remarkable. The fact that they've made this available as open source is also a huge plus. It opens up a lot of possibilities for further research and development. I'm excited to see what the community does with this.
Absolutely. And they've made it easy to run, too. They provide clear instructions for using llama.cpp, Ollama, and even VLLM. They even addressed potential issues with chat templates and token mappings. They thought of everything.
It's clear a lot of thought and effort went into this project. This is a significant contribution to the field of large language model optimization. Fantastic work.
Indeed. It's a testament to the power of creative engineering and open collaboration. So, listeners, if you're interested in running DeepSeek-R1, check out the links in the show notes. And don't forget to give them a star on GitHub. Thanks for tuning in to Tech Bytes and News. Have a great day.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into a fascinating article detailing a secure architecture using Keycloak, Angular, and the back-end for front-end, BFF, pattern. It's all about keeping sensitive data out of the browser, a crucial aspect of modern web security, you know?
Absolutely. The browser is a notoriously hostile environment. So what's the core idea behind using a BFF in this setup? I'm particularly interested in how it improves security.
Precisely. The BFF acts as a secure intermediary. Think of it as a trusted bodyguard between your Angular app, our untrusted client, and Keycloak, the authentication server. The BFF handles all the OAuth 2 and PKCE flows, keeping token management entirely server-side. The Angular app remains blissfully unaware of the complexities of Keycloak's API.
So the Angular app only talks to the BFF, which then communicates with Keycloak? That's a clean separation of concerns, right? Sing it. It simplifies things for the front-end developers, too.
Exactly. Architectural clarity is a huge win. The services remain blissfully unaware of each other's internals. And from a security standpoint, it's brilliant, because sensitive data, like tokens, never touches the client. It's all handled securely on the server within the BFF.
I see. But isn't this just a fancy proxy? What truly distinguishes a BFF from a simple proxy?
That's a great question. A BFF is more than just a simple proxy. It's a tailored solution. A proxy simply forwards requests. A BFF adapts the interactions to the specific needs of the client. It handles client-specific logic, aggregates APIs from multiple back-end services, and maintains a clear separation of concerns. It's a strategic architectural pattern, not just a simple routing mechanism.
Okay, got it. So let's talk about Keycloak. The article mentions using a pre-configured deployment with a test realm. What are the crucial Keycloak settings we need to pay attention to?
The most important settings are related to the volumes in the Docker Compose file. These define the paths to the test-realm.json and the certificates folder. You'll need to adjust these paths based on your local setup. Also, the public client settings in Keycloak are crucial. You need to specify the allowed URLs. In this case, those starting with https://localhost port 3000/- to ensure only the BFF can communicate with Keycloak.
And what about the BFF itself? The article uses express.js, but it could be implemented with other frameworks, right?
Absolutely. The author chose Express.js for simplicity, but you could easily use Nest.js or any other suitable framework. The core concept remains the same: a secure intermediary handling authentication flows and token management. The important parts are the CORS configuration to allow communication with the Angular app, the session handling for secure token storage, and the Passport.js Keycloak strategy for authentication.
The article highlights 3 key API endpoints in the BFF: /auth/keycloak, /auth/keycloak/callback, and /auth/logout. Can you elaborate on their roles?
Sure. /auth/keycloak initiates the authentication process with Keycloak, handling PKCE. /auth/keykloak/callback is where Keycloak redirects after successful authentication. Finally, /auth/logout handles the logout process, ensuring both the BFF and Keycloak sessions are terminated. It's a carefully orchestrated dance between the BFF and Keycloak.
Interesting. And how does the Angular application interact with this whole setup? It seems pretty straightforward, but I'd like to hear your take on it.
The Angular app is remarkably simple. It uses a service, auth.service.ts, to handle login and logout. It opens a pop-up window to interact with the BFF's endpoints, and then listens for messages from the BFF to determine success or failure. No direct interaction with Keycloak. No complex token management. Just clean, simple communication with the BFF.
So the Angular app remains completely oblivious to the underlying authentication mechanisms. That's a significant advantage in terms of maintainability and security, isn't it? It also reduces the attack surface of the application.
Precisely. It keeps the Angular app focused on its core functionality, while the BFF handles the security heavy lifting. This separation of concerns is key to building robust and secure applications. It's a modern approach to authentication that prioritizes security and simplicity.
This is a really compelling approach. Thanks for breaking it down. It's clear that this architecture offers significant advantages in terms of security and maintainability.
My pleasure. Remember, security is an ongoing process, and this BFF pattern offers a robust and scalable solution for protecting sensitive data in modern web applications. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll catch you next time.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into a fascinating project, BrainFlood, a runtime code generator for brainfuck using .NET Reflection. It's wild.
Wild is right. Runtime code generation? That sounds incredibly complex. What's the core idea here?
The author built a brainfuck interpreter, then a compiler that generates .NET code at runtime, all without using system.reflection.emit, which is usually the go-to for this kind of thing. The trick? Crazy use of generics and structs to force the JIT compiler to do a lot of the heavy lifting.
So no native modules, no reflection.emit. How does it even work?
It leverages several compiler optimization techniques. Think constant folding, inlining, and monomorphization. By cleverly structuring the code using generics and structs, the author essentially tricks the JIT compiler into performing these optimizations at runtime.
Interesting. So generics and structs are key here. How do they help?
Well, structs, being value types, force the JIT to generate separate code for each instantiation, achieving monomorphization. This, combined with aggressive inlining, allows the compiler to optimize the generated code significantly. The author even uses a custom system for representing integer constants as nested generic types.
Nested generic types for constants? That's something. It sounds like a recipe for unmaintainable code, but somehow it works.
Exactly. It's incredibly unconventional. The author admits it's probably not the most practical approach, especially outside a sandboxed environment, where system.reflection.emit would be a much simpler solution. But the performance benchmarks are surprisingly good, especially considering the constraints.
So what are the benchmarks showing?
The benchmarks compare the author's interpreter, Nayuki's optimizing compiler, and the runtime code generator. The runtime generator isn't as fast as Nayuki's, but it's significantly faster than the basic interpreter, and it's all happening at runtime. It's a testament to the power of the JIT compiler, even when pushed to its limits.
Impressive. But why go through all this trouble?
The author says it's mostly for fun and to show what's possible. It's a clever demonstration of how to manipulate the .NET runtime to achieve unexpected results. It's also inspired by another project called DEXTR, which compiles WebAssembly at runtime.
So this is a proof of concept, a stepping stone towards something more ambitious. What's next on the agenda?
The author wants to tackle WebAssembly compilation next, which is a much more complex undertaking. It'll require more sophisticated control flow and data flow analysis. It's a daunting challenge, but if successful, it could be a really interesting comparison to DEXTR.
Definitely something to keep an eye on. This whole project is a fascinating example of creative problem solving and pushing the boundaries of what's possible with .NET. Separate. Thanks for the summary.
You're welcome. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll see you next time. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into a fascinating discovery about the interconnectedness of ocean bacteria. It's totally mind-blowing.
I'm all ears. What's the big reveal? Is it about, like some new species?
Not exactly a new species, but a completely new understanding of how existing ones interact. We're talking about Prochlorococcus, the most abundant photosynthetic organism on Earth, responsible for a huge chunk of our atmosphere's oxygen. Trillions upon trillions of these tiny cells.
Wow, so what's the connection? Are they, forming colonies?
Better than colonies. Researchers found they're connected by nanotubes, tiny bridges of cell membrane that allow them to share nutrients and other resources. Think of it as a massive, underwater bacterial internet.
Nanotubes. That's incredible. I always pictured bacteria as solitary creatures. This changes everything, right?
Absolutely. This challenges the fundamental idea of bacteria as isolated entities. The study, published recently, shows these nanotubes connecting not just Prochlorococcus cells, but also with Synechococcus, another common ocean bacterium. They've even observed this in wild seawater samples.
So they're actively exchanging stuff? Like what kind of stuff?
Exactly. Experiments show the transfer of things like amino acids, enzymes, even toxins. It's a complex exchange network, and it's not just a one-off thing. This is a pretty consistent observation.
But why? Prochlorococcus gets energy from photosynthesis, right? What do they need to share?
That's a great question. They have surprisingly small genomes, meaning they lack the genes to produce all the nutrients they need. The nanotubes provide a way to efficiently exchange these missing metabolites with their neighbors. It's a form of cooperation, a symbiotic relationship.
Ingenious. So this network could impact things like oxygen production and carbon sequestration?
Potentially, yes. The scale of this interconnectedness is enormous. We're talking about a significant portion of the planet's photosynthetic activity. The implications for climate change and ocean ecosystems are huge and still being explored.
This is truly revolutionary. It makes you wonder what other hidden networks are out there, right? What other assumptions about bacteria might need revising?
Precisely. This research is a game changer. It highlights the complexity and sophistication of even the smallest life forms. The ocean isn't just a soup of individual cells. It's a vast, interconnected network of communication and cooperation.
It's amazing how much we still have to learn. This completely shifts our understanding of the ocean's ecosystem. Thanks for sharing this incredible discovery.
My pleasure. And to our listeners, thank you for tuning in to Tech Bytes and News. We hope you found this as fascinating as we did. Have a great day, and we'll catch you next time.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into the early reviews of the NVIDIA RTX 5080. It's generating quite a buzz, wouldn't you say?
Absolutely. The 8.3% performance boost over the 4080 Super is a pretty significant claim, especially considering the initial rumors suggested even greater gains. What's the catch?
Well, the initial review, leaked from Igor's lab, focuses solely on 1440p benchmarks without ray tracing or upscaling. That's a crucial detail. It's raw performance, but not the whole picture. We need to see 1080p and 4K results to get a complete understanding.
I see. So this 8.3% advantage is only under specific conditions? That's a bit less exciting than the 10% over the 4090 that was rumored, right?
Exactly. Those earlier rumors were, quite ambitious. This early review tempers expectations. It's a solid improvement, don't get me wrong, but not a revolutionary leap. The 8.3% increase is still impressive, though, especially considering the power consumption.
Speaking of power, what are we looking at there? Is it a significant jump?
According to the leak, the RTX 5080 averages 289.7 W, just 12 W more than the 4080 SUPR. That's relatively manageable, especially given the performance increase. It's not a huge power hog.
That's good to hear, but a leaked review. Isn't that a bit unprofessional? Doesn't that raise concerns about the accuracy of the data?
You're right to be cautious. It's definitely not ideal. A premature leak always casts a shadow of doubt. We'll need to wait for the official reviews to confirm these findings and get a more comprehensive picture. The official embargo lifts soon, so we'll have more data shortly.
Definitely. I'm eager to see the full picture, especially the 4K benchmarks. That's where the real performance differences often become apparent. And of course, ray tracing performance is a huge factor for many gamers.
Precisely. The 1440p no RT results are just a slice of the pie. We need the full picture before we can make any definitive judgments, but early indications are promising, even if not as groundbreaking as some had hoped. Thanks for tuning in to Tech Bytes and News. We'll keep you updated as more information becomes available. Have a great day.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating piece about the historical significance of old video game magazines. It's a real trip down memory lane.
Yeah, I saw this article too. It's amazing how these seemingly disposable magazines are now considered vital historical documents. I mean, who would have thought?
Exactly. Think about it. Before the internet, these mags were the source of gaming news, reviews, and community interaction. They were the lifeblood of the gaming world.
And now, so many of them are gone, lost to the pulping process. The article mentions the author's own experience witnessing mountains of magazines being destroyed. A real tragedy.
A total tragedy. But there's a silver lining, thankfully. The Video Game History Foundation, VGHF, is digitizing a massive archive of these magazines. Over 1,500 issues so far.
That's incredible. Fully searchable too. You can track down early mentions of anything from Minecraft to John Romero. Amazing detail.
Precisely. It's not just about nostalgia. It's about providing crucial context for understanding the evolution of the gaming industry. The article points out that these magazines reflect the social and cultural landscape of their time.
Right. The article highlights the stark gender imbalance in early gaming magazines. Mostly male characters featured, even in games that didn't necessarily focus on male protagonists. It's a revealing glimpse into the industry's past.
Absolutely. The advertising is another fascinating aspect. Those ads with scantily clad women, even for games like military shooters, speak volumes about the target demographic and marketing strategies of the time.
It's a reminder that the gaming industry wasn't always as inclusive as it strives to be today. The letters pages are also mentioned as a valuable source of information about player culture and conversations surrounding games.
You're right. The VGHF and the National Video Game Museum are doing incredible work preserving this history. They're reliant on donations, though, so it's important to support their efforts.
Definitely. It's a race against time, you know? Many publishers have lost their own archives, highlighting the importance of these independent preservation efforts.
Precisely. The article also challenges the idea of a linear narrative in video game history. These magazines show the uncertainty and complications that existed even back then, the lack of consensus on which games or technologies would succeed.
That's a really important point. It's easy to look back with 2020 hindsight, but these magazines offer a glimpse into the genuine uncertainty and excitement of the time. A fascinating perspective.
Indeed. So next time you're feeling nostalgic or interested in the history of gaming, check out the VGHF's digital archive. It's a treasure trove of information. Thanks for joining us on Tech Bytes and News.
Thanks for having me, and a big thank you to the VGHF and all those working to preserve this important piece of gaming history. Goodbye, everyone.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into DeepSeek's multi-head latent attention and other clever KV cache tricks for speeding up large language models. It's amazing stuff.
I'm really excited about this. The article mentions a story writing analogy, rereading the whole story for each new word. That perfectly captures the computational burden of self-attention in LLMs, right? It's quadratic complexity, O(n) squared, which explodes as the text gets longer.
Exactly. And that quadratic complexity becomes cubic, O(n) cubed, when generating text one token at a time. Think about it. Generating a twice as long text takes 8 times longer. That's a huge problem. But the solution, KV caching, is elegant. We store keys and values for each token, avoiding redundant computations.
So we trade memory for computation. We compute keys, k equals xwk, and values, v equals xwv, once per token, and then reuse them. That's a smart trade-off. But the memory cost still scales linearly with sequence length, right? That's where the real challenge lies.
Yeah, you're spot on. The memory usage can be massive, especially for large models. The article gives a concrete example with Llama 370B, over 20 gigabytes for just 8 sequences of 1,000 tokens each. That's why there's been so much innovation in optimizing KV cache usage.
And that's where the 11 papers come in, offering different approaches. There are token selection methods like Heavy Hitter Oracle, H2O, which prioritizes important tokens based on attention scores. Then there's Stream LLM, focusing on attention sinks, those initial tokens that anchor attention. Fascinating.
I see. And VATP combines attention scores with value vector properties for even more precise prunings. It's incredibly clever how these papers tackle the problem from different angles. Then we have post-hoc compression techniques like FastGen, which adapts compression policies based on runtime attention patterns. Very interesting.
And DMC uses adaptive token merging, effectively compressing the information. And there's even a simple L2 norm-based compression method. Surprisingly effective. It's amazing how much can be achieved with relatively simple techniques.
Yeah, it is. But the architectural redesigns are even more radical. MQA shares a single key value head across all query heads, drastically reducing memory but potentially sacrificing quality. GQA offers a nice compromise, grouping heads to balance speed and quality. Brilliant.
And then there's DeepSeek's MLA, using low-rank latent compression to maintain per-head flexibility while reducing the cache size. It's a really innovative approach. I also found SnapKV and Yoko interesting, with their windowing and global cache strategies respectively.
Totally. SnapKV's observation window and YOCO's global cache are both elegant solutions. It's remarkable how many different ways researchers are tackling this fundamental challenge. The field is exploding with innovation.
It really is. This whole area of KV cache optimization is crucial for scaling LLMs. The improvements in speed and memory efficiency are dramatic. It's a testament to the ingenuity of the research community.
Absolutely. From the simple story writing analogy to these sophisticated techniques, it's been a fascinating journey. And remember, this blog post was mostly AI generated, which is pretty mind-blowing in itself. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the world of KV cache optimization. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving deep into the fascinating concept of slicing the fourth, exploring the complexities of higher dimensions. Let's start with the basics. What even is a dimension? It's simply a direction, right?
Exactly. Think of a person confined to a line, one-dimensional. They can only move left or right. Add a ladder, and suddenly they can move up and down too. 2 dimensions. We represent their position with X and Y coordinates. But how does this relate to a 4th dimension?
That's where it gets really interesting. Imagine a 2D being, let's call him Oliver, observing our 3D world. He only sees the cross-section of objects intersecting his 2D plane. A finger passing through his plane appears as a circle, a cube as a square. This is analogous to us trying to understand a 4D hypercube.
So a 4D hypercube, a tesseract, is like a cube made of 8 cubes, just as a cube is made of 6 squares, and a square of 4 lines. It's a beautiful pattern. But how do we visualize it?
We can't directly perceive it, but we can understand it through its cross-sections. If a hypercube moves through our 3D space, we'd see a series of changing 3D shapes, starting as a point, growing into a cube, becoming more complex, and then shrinking back to a point. The math gets involved, using rotation matrices to describe the hypercube's orientation.
Right, the rotation matrices are crucial. They allow us to rotate objects in 3D space, but the article also discusses extrinsic rotations, where the axes of rotation remain fixed. This is important because matrix multiplication isn't commutative. The order matters.
Precisely. And the math gets even more intricate when we consider a rotated hypercube. The cross-section we observe isn't a simple cube anymore. It becomes a more complex shape, like an irregular hexagon. The article even provides the equations to describe this shape.
Wow, that's a lot of math. But the article cleverly uses this complex math to illustrate a simple point. Even though we can't directly see the fourth dimension, we can infer its existence through the changing cross-sections we observe.
Exactly. And it's not just about cross-sections. The article also touches upon projections, another way to represent higher dimensions in our 3D space. It's a more straightforward method, simply truncating the fourth coordinate to visualize the 4D object.
So the key takeaway is that while we can't directly experience the fourth dimension, we can use mathematical tools and analogies to understand its properties and how it might manifest in our 3D world. It's a mind-bending concept, but the article makes it surprisingly accessible.
Absolutely. It's a testament to the power of mathematics to help us grasp concepts beyond our immediate sensory experience. And that's all the time we have for today's episode of Tech Bytes and News. Thanks for joining us, and we'll see you next time. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving deep into Svelte 5 and its impact on the future of web frameworks, based on a recent Smashing Magazine interview with Rich Harris, the creator of Svelte. Get ready for some exciting insights.
I'm pumped. Svelte 5 has been generating a lot of buzz. What's the core takeaway from this interview?
The big picture is this. Svelte 5 isn't just an update, it's a complete rewrite, marking a significant maturation of the framework. Think of it as a fresh start, building on years of experience. They've replaced the magic feeling dollar with more explicit syntax, like $state, $derived, and $effect, making it more transparent and easier to learn.
So more explicit, less magic. Interesting. Does this mean Svelte is abandoning its unique approach?
Not at all. The core philosophy remains. Rich Harris emphasizes building high-quality, resilient, and accessible apps. He even outlined 10 guiding principles, including prioritizing developer experience and focusing on the quality of the web itself, rather than just raw performance metrics. He's not chasing raw adoption numbers. He's aiming for quality.
That's a refreshing perspective. Many frameworks seem obsessed with sheer numbers. But what about scalability? That's often a concern with frameworks like Svelte.
That's a great point. The interview directly addresses that. While Svelte 5's improved clarity and explicitness enhance maintainability, which indirectly boosts scalability, the focus isn't solely on competing with React or Vue in terms of sheer scale. The emphasis is on building better, more maintainable applications. It's a different approach, a more sustainable one, I think.
I see. So it's less about raw power and more about building better software? What are the next steps for Svelte, according to Harris?
Exactly. Harris sees a need for improvement in the broader ecosystem. He wants to tackle ancillary problems like data loading, data persistence, deployment, and even potentially creating a full-stack solution, similar to Rails or Laravel, but for JavaScript. He envisions a more integrated, less fragmented development experience.
That's ambitious. A Rails for JavaScript, that's a bold vision. What about the community response to Svelte 5? Is it positive?
Absolutely. The response has been overwhelmingly positive. Weekly NPM downloads have doubled since the release, and the community is buzzing with new projects. The interview highlights several examples, like WebVM, a virtual machine for the web, and SvelteND, a drag-and-drop library. It's a vibrant ecosystem.
So, for developers considering Svelte 5, what's the message?
Harris's advice is simple. Give it a try. He points to a tutorial that can get you building applications in just a few hours. There's really nothing to lose. It's a framework that prioritizes developer happiness and building quality software. And that's a message I think resonates with many developers. It's a refreshing change of pace.
Absolutely. Thanks for this insightful summary. It sounds like Svelte 5 is more than just a framework update. It's a statement about the future of web development. A focus on quality over quantity.
Precisely. And that's a wrap for today's Tech Bytes and News. Thanks for tuning in, and we'll catch you next time with more exciting tech updates. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into Hawkeye, a really cool license header checker and formatter checker. It's available in multiple formats, which is awesome. So versatile.
Yeah, I saw that. Multiple distribution forms. That's a key selling point. But what exactly does it do? I mean, beyond the name suggesting it's sharp and focused,
Exactly. It checks and formats license headers in your code. Think of it as a super-powered, automated code hygiene tool. You run Hawkeye Check to see if your headers are correct, Hawkeye Format to fix any issues automatically, and even Hawkeye Remove if you need to get rid of them. Pretty neat, huh?
I see. So it's command line based. How does it integrate with workflows?
Totally command line. But it plays nicely with GitHub Actions, Docker, and even Arch Linux via Pacman. For GitHub Actions, you just add a step to your workflow using their action. You'll need a licenserkey.com/config file to specify your license and copyright details. It's super straightforward.
That's slick. And the Docker image, how big is it?
Only about 18 megabytes. A tiny Alpine image. That's a huge advantage for speed and efficiency. They also offer a cargo install and pre-built binaries for even more flexibility. Amazing!
Right. The configuration options seem pretty extensive. I noticed things like base dir, inline header, header path, and a whole bunch of include/exclude patterns. It looks very customizable.
You're spot on. The licenserc.tom file lets you fine-tune everything. You can specify your license header file, use inline headers, define include and exclude patterns using gitignore-like syntax, and even customize keyword checks. It's incredibly powerful for tailoring it to your project's needs.
Interesting. But what about the header style itself? Can you define custom styles?
Absolutely. You can create custom header style files. These files let you specify things like the first and last lines, characters to prepend and append to each line, whether to allow blank lines, and even regular expressions to detect the start and end of the header. It's highly configurable.
So it's not just about checking Apache 2.0 licenses. It's adaptable to various license types?
Precisely. The configuration allows you to adapt it to any license type. The flexibility is a major strength. The project's history is also interesting. It started as a Maven plugin and was rewritten in Rust for better performance and smaller Docker image size. A smart move, I think.
I agree. Rewriting it in Rust for a smaller Docker image is a clever optimization. It shows a good understanding of the trade-offs involved in software development. Very impressive.
Absolutely. And the documentation is quite comprehensive, making it easy to get started and customize it to your specific needs. Overall, Hawkeye is a fantastic tool for maintaining consistent license headers across your projects. It's efficient, flexible, and well-documented. A must-have for any serious developer.
I concur. Thanks for breaking down Hawkeye for us. It sounds like a valuable addition to any developer's toolkit.
You're welcome. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll catch you next time. Goodbye.
Bye-bye. Thank you for listening to the daily roundup of Tech Bytes and News. See you again tomorrow. Goodbye.